guys, welcome to my channel. This afternoon we'll be talking about organic chemistry and what is the beauty behind these particular topics in chemistry, because when talking about the three branches of chemistry, we have the physical part, we have the inorganic part, and we have the last one, which is the organic chemistry part. So I'll be taking you guys or showing you guys the beauty of organic chemistry. And to my notice, I discovered that many students in chemistry find it difficult to understand these particular topics. So now, when talking about this now, I can say there are branches of chemistry that deals with carbon, or we say carbon compound, because in college we call it carbon compound. Are you with me now? And again, we should take note of what we mean by catenation. When talking about this catenation, it means that ability for carbon to form a longest carbon continuous chain like this is called catenation. And don't forget that organic chemistry is the branches of chemistry that deals with carbon compound, or we call it the chemistry of carbon compound. And again, when talking about carbon compound, take note the exemption of carbon dioxide, carbon dioxide, and trioxocarbonate 4. All these are exempted when talking about the chemistry of carbon compound. That is for the definition of organic chemistry now. And now let's go back to what we mean by hybridization. Hybridization of carbon. Don't forget, the first thing we talk about is hybridization of carbon is that, first and foremost, what is the meaning of hybridization? Hybridization to wide chemistry level, we can say that it is a mixing of atomic orbital to equivalent molecular orbital. Example of that hybridization now. So let's take that of the carbon. Don't forget, carbon belongs to group 4 in the periodic table, and its electronic configuration is given to be 1s2, 2s2, 2p2. So now, what is the hybridization of this now? Take note that our 1s have this particular degenerate orbital, which is 1s. Our 2s have 2 electrons, and our p, we are 1, 2. So we're talking about the mixing of atomic orbital to equivalent molecular orbital. I'm going to pick one with the example of this hybridization to help some college students also. I have barium chloride. Are you with me now? So now let's take out or the electronic configuration of barium. Barium belongs to, I have atomic number of 4, so I have 1s2, 2s2. Are you with me now? For beryllium now. So now the next one is chlorine, and before we draw the electronic configuration of chlorine, mind you, we have 2 of chlorine. So now this one will represent what we call by helium core, and the 2s have this orbital 1, 2. Why my beryllium does not have any element in the p orbital? Mind you, our chlorine is 2. So now let's deal only with the outer electron of chlorine. So the electronic configuration, we have 1s2, 2s2, 2p6, 3s2, 3p5 for chlorine. So the outer electron will be the addition of these 2 plus 5, we have what? 7. So it's that. I can say that this one we have here is equivalent to neon. So chlorine have what we mean by neon core. Then the outer electron have 3s2, 1, 2, and for my p I have 5. 1, 2, 1, 2, 3, 4, 5. Are you saying it now? So mind you, you have 2 chlorine. So let's pick the second one to be this. 1, 2, 1, 2. We have 1, 2, 3, 4, 5. And one thing you should take note of is this beryllium here. What you have here, I can call it ground state. Why? Because when talking about ground state, it means that they have not yet what? They are still under hybridization. So we call it before hybridization. It's not to be the ground state now. And mind you, for this here, we have 2 electrons for the p orbital. So how does this particular one here undergo what we call excited state? That is after hybridization. You draw out you repeat the same thing for your p orbital. So one of these electron here will come into this place. So I have it like this because when is this particular dot cross here, it means that we are introducing new electron into the p orbital. And mind you, for this we have 1 electron here. For this we also have what? 1 electron here. So this one here will move to this place while this will move here. So I have the first chlorine while this one represents what? The second chlorine. So I can call this one excited states. Yes. Or we call it after hybridization. Are you with me now? So with that, now we have talked about the hybridization of carbon. Then we relate it back to a good example of barium chloride now. So what is the shape of this? I have chlorine to B. I have beryllium here. I have what? This here, chlorine here. So mind you, this is 180 degrees. So they are linear in shape. So that is for hybridization. And relating it back to that, organic chemistry that deals with the chemistry of carbon compound, with the exemption of carbon dioxide, carbon dioxide, and trioxocarbonate. And again, take note that ability for carbon to form a longest continuous chain is known to be catenation. So now let's go back to what we mean by hybridization. Under this hybridization, we talk about the categories. We move to the groups of hybridization. Then we start with what we mean by alkane. So now, listen class. We have hydrocarbon. Are you saying it now? What is the meaning of hydrocarbon? Don't forget that word from hydro and carbon. So we can say that they contain 2 elements, hydrogen, and we also have carbon. So hydrocarbon can be defined as a combination of 2 elements. To give what we mean of that word, hydrogen and carbon. And take note that all the formula we have under organic chemistry, all organic compound, have been derived from this hydrocarbon. With that, I said the general molecular formula of hydrocarbon is CXHY. These X and Y are meant to be O numbers. So my X can represent 1, my Y can represent 1, my X can be 2, my Y can be what? 2 now. So let's go back to what we mean by the categories of hydrocarbon. So those that are taking Y, Jamb, NECO, and GCE, I will take it down to your level. The first one we have is aliphatic hydrocarbon. The second one is alicyclic hydrocarbon. Y, the third one is aromatic. So look at these 3 categories of hydrocarbon. So let's pick it one by one. What do you understand by aliphatic hydrocarbon? They are the categories of hydrocarbon that deals with open chain. So I can say for aliphatic we have open chain hydrocarbon. So that is the way the carbon atoms are arranged. They are arranged in an open chain. Example of this, I have butane. And don't forget the molecular formula of butane is C4H10. So how does butane relate to aliphatic? Because I said that aliphatic are categories of hydrocarbon in which the carbon atoms are arranged in open chain. Many we have 4 carbon atoms here, and here we have 10. So we have 1, 2, 3, 4. Then the next one is hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see that it's obvious that this is arranged in open chain. Are you getting me now? So the next one is alicyclic. They are categories of hydrocarbon which are arranged in ring structure. So I can say they are cyclo. An example of this, I can pick anyone. Okay, we have cyclobutane, or we have cyclopropane. So we have C3H6. So let's check. We have one carbon, the second one. So we have 1, 2, 3, 4, 5, 6. I said it now. They are arranged in ring also. But one thing you should take note that aromatic are also arranged in ring, but they are special group of carbon. That is the way the carbon atoms are arranged in ring are alternates to each other. Why are they alternate to each other? One thing you should note about aromatic is the meaning of these alternate to each other is because they contain both single bond and double bond. So an example of this aromatic, we call it benzene. We also have naphthalene. We have many like that. But this benzene is a good example of it. So we have 6 Cs, 8 Cs. So we have 6 carbon atoms and 6 hydrogen atoms. And let's see how they are alternate to each other. That is the combination of double and single bond. So we have 1, 2, 3, 4, 5, 6. So I have the double bond, the single bond, the double bond, single bond, double bond. I have one single bond. It's obvious to me that this is what alternates to each other. I say it now. Then the hydrogen is 6. 1, 2, 3, 4, 5, 6. That is for the categories of hydrocarbon. To me, also what I mean by the groups of hydrocarbon. So before we move to the groups of what? Hydrocarbon, I would love to sketch out the way I'll be treating my organic chemistry class. I have this to be aliphatic. I have this to be alicyclic. And I have this to be aromatic. So now, my main focus now for the organic chemistry one will be on aliphatic. So the first member here we have alkane, we have alkane, we have alkyne, I have alkanol, I have alkanoic, I have alkana, I have alkanon. These are pick the aliphatic. And again, I classify the groups of hydrocarbon to be saturated and also to be unsaturated. So my own knowledge on hydrocarbon, you can see it now. And now let's pick it one by one. What do I mean by this saturated hydrocarbon? After these two, then we now move to what I mean by alkane. So now, for saturated hydrocarbon, they join carbon to carbon in a single, these are single covalent bond without further attachment of any other atoms. If you look at example of saturated hydrocarbon, does it attach any other atoms? No. Example, I can just pick any member of alkane, which is ethane. I have C2H6. Let's see if there is no space for further attachment of any other atoms. With that, I have 2 carbon atoms. You can see it now. No space for me to attach any other atoms here. But when we move to this saturated here now, they join carbon to carbon in a double, triple covalent bond with further attachment of other atoms. Example now, let me pick one example under alkane. One example under alkyne. For this, I have C2H4, I have C2H2. So let's show how they attach or attract more atoms to themselves because they are in open space compared to saturated. 2 carbon atoms, double bond. 1, 2, 3, 4. For the second one, triple bond. 1, 2. Are you saying that they are different from each other? And don't forget earlier when I was treating the molecular aspects that if there is single bond, sorry, under isomerism, if there is single bond, there will be free rotation. Now, if you have double bond, it will need to restrict the rotation. The same thing to this. It's going to restrict the rotation. And don't forget that for every double bond, you have a pi bond and a single bond. So let's start with the first member of aliphatic. So, is what? Alkane. So, what is alkane? Is alkane. I will pick out the main things you ought to know under this alkane. Alkane. They are generally known as paraffin. Many students don't know that alkane are generally known as paraffin. Are you saying it now? And they also can also say that they belong to homologous series with general molecular formula CnH2n plus 2. So now let me explain this homologous series. As soon as I start the naming of alkane, I will show you guys the meaning of these homologous series. But before then, they differ in the way the carbon atoms are arranged with the addition of CH2. So all member of alkane or aliphatic undergoes what we mean by homologous series. And again, the general molecular formula of alkane is CnH2n plus 2. And take notes, the first 4 member of alkane are gases. Are you with me now? Methane, ethane, propane, and butane. The first one are what? Gas. While others are liquid. Are you with me now? So now, let's take this particular formula to the meaning of what we mean by homologous says that the addition of CH2. So now, I will take the second heading to be what? Naming of alkane. And take notes before we start the naming. When naming alkane, the general molecular formula must be obeyed. And what's the formula? This. And in case they ask you that, what is the functional group of alkane? This is the functional group. Functional group of alkane. So let's start it now. We are having that N there. N there represents O number. So when N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4, N is equal to 5. So let's pick this first. Then we have N is equal to 6, 7, 8, 9, and then is equal to 10. With that particular formula, that we must obey it when naming any alkane. The first formula is C times N will give us what? C. 2 times 1 here will give us 2 plus 2 we have CH4. This member is named methane. And again I said addition of CH2. If I should add my CH2 to this, I'm using a particular formula, we have a C2H6. This compound is named ethane. The next one, add CH2 to it using the homologous series. CH3, we have what? This is named to be propane. And don't forget, if you are not good in using a particular formula, then you can go back to your homologous series that it is differ with the addition of CH2. Are you with me? So now we have C4H10. This compound is named butane. C5H12. This compound is named pentane. So C6H12, 14. We have this to be hexane. C7H16. I have this to be heptane. C8H18. I have this to be octane. C9H20. I have this to be nonane. And C10H22. I have this to be decay. You can see all this now using this particular formula. And again, if you don't want to use that, I can decide to go with homologous series now. So you can see we have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decay. So now the next one to pick here is the structural molecular formula of alkane. So now I will be making use of this methane, ethane, and propane, those three members of alkane. How do we have the structural formula and how do we have the molecular formula? For methane, I have this to be the molecular formula, and this CH4 to be my MF molecular formula, SF my structural formula. Don't forget, molecular formula, structural formula. So the next one is ethane. The molecular formula of my ethane is this. So how many carbon atoms do we have here? I have 2. So 1, 2, 1 hydrogen, third, second, third, this. So what is my molecular formula? I have CH3, CH3. That's changed now. Are you with me now? So the next one is propane. I have 3 carbon atoms and 8 hydrogen atoms. 1, 2, 3. I have this. I have this. So we have CH3, this, CH2, this, CH3. You can see all these are the molecular formula of methane, ethane, and propane. And take notes to the Jamb students who are that there's a between molecular formula and structural formula. I think I gave explanation on that last week, and I solved some question under the molecular formula, the structural formula. So now, class, let's take note again before I move on. This particular formula I have here must be noted to be the formula of alkene. So the next thing to speak of now is what do we mean by alkene? Alkene, and alkene is derived from the parent alkane. So let's show us that truly alkene is derived from the parent alkane now. So I have alkyl group. Alkyl group. Alkyl group is derived from the parent alkane. So they are derived from the parent alkane with the removal of 1 hydrogen atom. They are name ANE with YL with general molecular formula CnH2n plus 1. This is a formula of alkene. Why? Because they are named from the parent alkane and also removal of one hydrogen atom from the parent alkane. So let's go to the naming of alkene. Naming of alkyl group. So let's do it the way we did for the first one. I only pick from 1 to 6 or 5, then you can practice it out yourself to see or to confirm the formula. And again, don't forget, I can also use this formula in place of homologous series with the addition of CH2. So for this now, I said CH3, this is named as Methane. Mind you, I got this from CH4, which is named to be what? Methane. So if I should remove this, I have YL. If I should minus 1, I have CH3. So this is called methane. The same the second member of alkane, I have C2H5. This is what? Eth. Then I can also have the structural or molecular formula to also be what? CH3CH2. The next one is CH3. So we have propene from propane. I'm going to remove that in with YL. So I have this to be CH3, CH2, CH. Don't forget, these are the molecular formula, MF. So when n is equal to 4, this is 3, 2, 1, 4, 5, 6. C4, H, 9. I call this Butsy. So we have CH3, CH2, CH2, CH2. But we are having it like I can also say that what? CH3, open a bracket, CH2. How many do I have? 1, 2, 3. 3 outside. So C5, H11, I have penti. So with this, the same thing, you have CH3. Because of this, open a bracket, CH2, we have 4 here. Then the next one, C6, H13. This one is called XZ. So I have CH3, put in bracket CH2, close it, we have what? 5. So you can see that under the alkane I call CH4 methane. But when you get to alkane, I say they are the removal of one hydrogen atom from the parent alkene. So the next one, again, which you ought to know, is called haloalkane. Some they call it alkalites. So I call it haloalkane. The formula for this is Cn H2n plus 1x. This S is the halo, while this is the alkane. And here, what are the haloalkane? We should know. Please don't forget this particular formula. So under this one now, anywhere I see fluorine in organic compound, it is not called fluorine, it is called fluoro. Anywhere I see chlorine, it is called fluoro. So anywhere I see bromine, it is called bromo. Anywhere I see iodine, it's called iodo. I'll stop here for today, and tomorrow don't forget to follow me on when I'll be teaching you guys how to name some series of organic compound. And earlier we talked about, I gave you guys the definition of organic chemistry, the meaning of catenation, the hybridization of carbon, and also I gave some example which is barium chloride. We talk about what we mean by hydrocarbon. So now I think we have covered many parts of aliphatic, which is what? Alkane. So tomorrow I will give you guys a Aliphatic lecture of alkane with some series of examples. So after that we move to the next member of aliphatic, which is alkane. So I will stop here for today. Don't forget to watch and don't forget to subscribe and share. Thank you.